Okay, so we are covering rational functions. And so rational functions are what happen, rational meaning ratio, when we take the ratio of two functions. And so we'll be asking for the domain for number one. And so the domain is what happens when you're looking for all values of x for which there's a solution. And so to find the domain, you set the denominator equal to 0 and solve, and that'll tell you the places where you do not have a value. So in this case, the denominator is x minus 2. You set that equal to 0 and solve. You add 2 to both sides, and you get x equals 2. So this is a place where the denominator is 0, and so you do not want x to be equal to 2. So that's the answer. It's A, and it's the domain of R is every x except for x equal to 2. We'll do the same thing with the next one. We'll set x minus 2 times x plus 8 equal to 0. And so again, this can only be 0 if x minus 2 is equal to 0 or x plus 8 is equal to 0. So the domain is everything except for 2 and negative 8. Subtract 8 on both sides. So you will put 2 here, comma, negative 8. Here we have some vertical asymptotes. And so for the ones that we just did, they would create vertical asymptotes. And so I think I want to zoom in a little bit here. Let me see if I can make this a little bit bigger. So let's do this. So notice around, we're going to negative 2. Negative 2 is right here. So negative 2 is right there. And so as x goes to negative 2, let me move this. As x goes to negative 2 from the left, so that signifies from the left. That means that when you look at this graph, here's negative 2. And so you're coming from the left of negative 2. So that means, I'm sorry, here is the left of negative 2. So you're on the left of negative 2. That means you're on the graph. And this graph, as you go to negative 2, goes to infinity. So you would put infinity there. As x goes to negative 2 from the left, it goes to infinity. And in a similar way, for this graph, their vertical asymptotes at, this looks like negative 2 and at 3. That's where this vertical line is. And as you go to 3 from the left, to the left of 3 is this side. So you get on the graph right above negative 3, I'm sorry, in this case 3. And again, you see the graph is going higher and higher the more you approach 3 from the left. And so this also is infinity. So you put infinity there. Excellent. I'll make that a little bit smaller. Okay. Here, we're going to actually find those vertical asymptotes, and this is not any different from finding the values where the domain is undefined. So again, you set, as long as you can't simplify, you set the denominator equal to 0. And so x plus 1 equals 0. And so you subtract 1 on both sides. And you get x equals negative 1. Now, the vertical asymptote is a line. So you have to write the equation x equals negative 1. So it's part A, and it's x equals negative 1. Same thing here. We'll set x times x minus 3 equal to 0, and that's two things. And so that means that either x is 0 or x minus 3 is equal to 0, in which case x is 0. We're adding 3 to both sides. X is equal to 3. So here, the vertical asymptotes are, and I think you can put in x equals 0, 3, like that, and that's the first option. Now, as we go through some of these other options might pop up, like this one. Here, if you set the denominator equal to 0 again, you get x equals 0. I'm sorry, let's do that, equal to 0. You get x equals 0, or x minus 7 is equal to 0. And so x equals 0, or x is equal, adding 7 to both sides, x is equal to 7. Now this is different because vertical asymptotes create problems. Okay, so x equal to 7 is going to be a vertical asymptote, but x equals 0 really doesn't cause us the same problem as x equals to 7 because there's an x up here that cancels out this x down here. And so because there's canceling, because you can cancel this x equals 0 problem, there is no vertical asymptote at 0. There's just a hole, right? And so that's why the answer for this one is B, because of the canceling. There's a vertical asymptote. I'm sorry, it's not B, it's C. There are vertical asymptotes at x equals 7, and there's a hole at x equals 0, and that is because the x term can cancel. That comes up here again when you have x minus 5. We'll set that equal to 0 like before, and x equals 5 is a serious problem. Now the question is, does this make it a vertical asymptote, or is this just a hole? And that means all we're asking is, can we cancel? And so we go look at the numerator and we see x squared minus 25, and we say, oh, well, x squared minus 25 is actually equal to x minus 5 times x plus 5. And so we can cancel this. Let's bring it back down. So we can cancel this, right? So it goes like this. This is actually equal to, I'll bring it up here, x squared x minus 5 times x plus 5 all over x minus 5. And so because that cancels, 5 is still a problem, but it's not a vertical asymptote. It is just a hole by itself. And so there are no vertical asymptotes, but there is a hole, and we would say at x equals 5. This one looks like the one that's going to be on the final. So here, the first thing we want to do is factor. And so it's x minus 6, that's the numerator. And so here we are again, where we need to find the factors of 30 that add up to 11. That would be 6 and 5. And they both have to be negative. And we see that now, x, you set them each equal to 0, like we did earlier. And we see that x equals 6 is a problem, and x equals 5 is a problem, adding 6 and 5 to both sides respectively. And then the question is, are these vertical asymptotes or are they holes? And we see that because the x minus 6 cancels, that makes this a hole. The x minus 5 does not cancel, and that makes it a vertical asymptote. And so we have answer C, that there's a vertical asymptote at x equals 5 and a hole at x equals 6. So what I want to do now is that I want to give some extra credit at this very moment, that for those of us in class Go ahead and do this one and bring it up to me today as you are doing this in class. X minus 5 all over x squared minus 7x plus 10. What are the vertical asymptotes and holes of that? And if you do that, then I'll add, let's say, 3 points to your test. So we'll make that plus 3 points right now. Okay. We'll add that to your lowest test. All right, so number 10 has to do with horizontal asymptotes. So for horizontal asymptotes, they're of the form y equals something. And so the way that you find them is according to the following rule. You look at the highest power, well, I should say the degree. We know what that means. We look at the highest power or the degree of the numerator and the denominator. And so an asymptote is what happens when x gets really, really large. So when x gets really large, when x goes to infinity, if the highest power in the denominator is higher than the highest power in the numerator, then the vertical asymptote is y equals 0. So since 2 is bigger than 1, the highest power in the denominator is bigger than the highest power in the numerator. When x gets big, 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 the whole fraction goes closer and closer and closer to 0. And you can put values of x in to verify that. And so when x gets larger, the whole function gets really, really small. That means that y equals 0 is a horizontal asymptote. And we're going to go through all of the possibilities. So of course, the 3 possibilities: the highest power in the numerator is higher than the highest power in the denominator. The highest power in the numerator is the same as the highest power in the denominator, or the highest power in the denominator is bigger than the highest power of the numerator. And that's the one that we just did. For number 11, we have the case where the powers are the same. The highest power in the numerator is 2. The highest power in the denominator is 2. So what you do in that case is when the degrees are equal, then you take the ratio of the coefficients. In this case, it's 24 over 6. 24 over 6 is 4. So this means that if you take x to be large, 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 then g gets closer and closer and closer to 4, right? So if you plug in larger and larger values of x, then g gets closer and closer to 4. And so y equals 4 is a horizontal asymptote. So we just did the case where, for number 10, where the largest power in the denominator was higher than the largest power in the numerator. Here, we're doing the case where the largest power in the numerator is the same as the largest power in the denominator. And then the final case is if the highest power in the numerator is bigger than the highest power in the denominator. And if that's the case, then this does not get closer and closer to anything as x gets larger and larger. So there is no horizontal asymptote when the highest power in the numerator is bigger than the highest power in the denominator. Okay, that's it. So I hope that helps. And again, here's the extra credit. Give that to me in class today. And I will add that to 3 points to your lowest exam grade. Hope it helps. I will talk with you soon.